Welcome to another video from Lockdown Electronics with me, Bill, and this time we've got some 1980s nostalgia in the shape of a retro rig, and that's none other than the Yaesu FT290. This is the Mark II version. Now, 34 years ago, round about this time, I was revising hard for my forthcoming radio amateurs exam, and back then, all those years ago, there was only one way to get an amateur radio licence. That was to take the City and Guilds exams. Things are so much better these days. I think it's probably harder now to get your licence, but there were certainly plenty of people I know who took the exam, passed it, got a licence, and never really got themselves on the air because there was no practical aspect at all. There was no practice at operating, and the license conditions were such that it was quite restrictive in terms of the messages that you could pass. But I was absolutely mad keen. I was determined to pass. In fact, I wanted to do a great deal better than pass, which I'm pleased to say I did. And then after that I went out and bought a radio, and the radio I bought was this FT290, not just any FT290. This is the actual radio that I bought all those years ago, and I think I paid just over £400 for it at the time from a radio shop in the West Midlands, who will remain nameless because I think it sometimes courts a bit of controversy. But I think if you do the maths and allow for inflation these days, that would be like spending about £1,200 on a radio now. So I think for £1,200 these days you can probably get an IC 7300, which is certainly got a lot more features than that. So let's start by having a look at the history of the FT290 and why it became a classic back in the 80s. Well, the year is 1981, and there were a couple of important technological events that occurred that year. One of them was the first flight of the space shuttle, and the other one was the introduction of the FT290R by Yaesu. It's a VHF 2-meter multi-mode, 2.5 watts output, FM, single sideband and CW. Ideal for portable working, not least because it was possible to fit batteries inside the case, so it would actually operate as a self-contained unit. It was a very popular radio actually, and proved very popular indeed. In fact, there's still you still find plenty on eBay even now. One of the reasons it was popular in 1981, the British government finally got around to permitting legalised CB. Up to that point, CB had been operated using illegal AM equipment, which had been imported from the States and elsewhere, and it had really grabbed the public's interest, and those people who got interested in it and wanted to take it further were coming into amateur radio hobby from CB, so it was a good time then. Some of them suffered poor sensitivity, and there was quite a popular mod, the Mutec front end, which was a relatively straightforward update for the radio, and that was certainly quite a popular addition. Angus Mackenzie, G3 OSS, he gave it a favourable review in the Amateur Radio magazine. It was 1983 when they got around to doing that review, but it was a good rig. Wind the clock forward 5 years and to 1986, and what happened that was famous in 1986? Well, not to be outdone by the space shuttle, the Russians launched the Mir space station. Mir, of course, meaning peace. And Yaesu introduced the FT290 Mark II. The previous one, of course, wasn't the Mark I, it was just the FT290, but everybody calls it the Mark I these days. It was absolutely identical in size and weight to the Mark I, although as you can see from those two little thumbnail pictures, it looked quite different. And it was actually a completely new design, outside and inside. A very different radio with quite a bit of additional circuitry. Yaesu had clearly listened to feedback regarding some of the fiddly nature of some of the controls on the original FT290, and they brought those controls onto the front panel so they were easily accessible, and they'd sorted out the poor sensitivity, and at last we had a decent front end. And the circuit used what was referred to by some people at the time as chip resistors. We would of course know them these days as SMD components, but that was relatively new back then. Chris Lorick reviewed it in January 1987 in Ham Radio Today magazine, and was suitably impressed, and I think that's probably a slight understatement. Chris knows his stuff about radio, and he gave it a very, very good write-up indeed. He was most impressed with it. So there we go. The 290 also had a stable mate. It had the 790, which was the 70 centimetre version, and there was also eventually a 690, which was the 6 metre version. Neither of which I actually owned, although I was quite tempted on occasion, certainly by the 690. Okay, well that's a little bit of the fascinating history surrounding this particular Yaesu rig and its predecessor, the Mark 1. So now let's take a closer look at it on the bench and see what it's like, because this hasn't been switched on for quite a long time, and I'm guessing it'll still work okay, but I just don't know. So let's have a look and see if the years have been kind to it. Okay, so here's the radio itself. Nice little compact unit. On the Mark 1, the Mark 1 was sort of all radio here, and the battery is fitted inside in a cover. But on the Mark 2, they fitted these rather strange clips, and the battery pack removes completely. It's then possible to fold that open, and I used to keep this has never been the easiest thing to open. They used to keep NiCads in here. You can see I took them out when I wasn't using them, which is why that's still nice and clean in there from a contacts point of view. And there's a little bit of circuitry to do with being able to charge, etc. There's a little push-through rod there which switches on the dial light, and you can latch it so that it stays switched on. The dial light went a long time ago, and changing it is a big job. I can live without the dial light. What was available, and you do occasionally see them, but they're quite rare, there was a 25 watt linear that was exactly the same size as that, which clipped on. Made a few connections, you can see here, and there's the antenna connection. When you put the linear on, it disconnected the front BNC and switched the dial light on and got the radio sort of ready to go. So that's that. The way you get DC in is through the battery pack there. That's the charging, and that's the DC supply, center negative. Center negative. So that clips on there, and in Chris Lorick's review, he was a little bit critical of those not being terribly robust. I have to say they've been alright for me. So microphone, fairly standard bit of kit really. It has up and down buttons on it, but it's just a fist mic. Interestingly, it's a dynamic mic element in there. So I don't propose to do a complete tear down, but I have taken out most of the screws. So we'll just have a quick look in the top part of the radio, if I can get it apart for you relatively easily. I think I can. I forgot I need to take the battery case off to do that. And these side panels don't need removing, but they do need just loosening slightly, because they can grip the side. Right, okay. Off comes the top, and there's a little speaker there, so you can hopefully see the inside of the radio if I can hold it still enough for a while. Just make sure that's looking like it's in focus. Not lovely sunshine this morning, but not great for filming. So judging by the number of IF transformers we've got in here. I suspect this is the receive section. Yeah, there's a filter there. So this is the receive board, the transmit board is the other side, and one of Chris Lorek's comments about what he called the chip resistors is there's SMD resistors mounted on the opposite side of this board, but again, got to do quite a lot of taking apart to get to it, and that rod there is works the dial light through a little push rod system. So yeah, nice little radio. That's the installment there to put the tone unit in. That was the 750 Hertz tone burst, which isn't really much use to me in the UK here anymore, but it certainly was at the time. I'll show you one or two photographs. Oh, there's also a fuse there as well, worth remembering. I'll just show you one or two pictures here that I've took with a macro lens of some of the electrolytic capacitors in the transmit side, and as you can see, here's a couple of them. As you can see, they are the tops of them don't look in any way bulged. I guess after 34 years they're probably not at their best anymore, but they're clearly not bulging or leaking, so that's quite handy. And looking around the electrolytics on here, it looks similar too, so hopefully she's still okay from that point of view and it's going to power up okay. So that's the top half. Just pop that back on for a second, and does have a nice well built feel to it, has to be said. So we've got volume, squelch, antenna output. The radio itself came with a rubber duck, as it used to be called, a helical antenna, which just clips on there, and it's nice and durable. The Mark 1 came with a telescopic antenna, and it was extremely easy to break, so you're lucky these days if you get one that's got the original telescopic antenna that's not been broken. And then we've got obviously the display, various buttons, and a function button here which gives you the second option on some of the controls here. Two VFOs, memories, and then we've got various scanning modes. We've got the noise blanker, power setting low and high, and then here's the setting for repeater, and you can also listen on input by pressing there. That's an analog clarifier for SSB, which is quite useful if you just want to net in on the receive. So all in all, a nice solid radio. So we'll get some power into it now and see how she sounds. Okay, well, got it powered up. I'm just going to bear in mind that it's centre negative on this plug, so you have to be very careful with things like that. I think it's most kits centre positive these days, but that's definitely centre negative. So I've put the wires in the way around to the power supply. So I've got it hooked up to my dual band vertical, and there was somebody on FM, so we'll see if we can find them. There we go.
Reminded me about how I won a pint of beer
So you can hear it's receiving absolutely fine. I've not got the microphone plugged in, so there's no danger of accidentally transmitting. I live in quite a rural location, so I wanted to just jump on here while there was somebody actually on simplex, so you could actually hear it on receive. I think these guys are in the York area, so for me that's probably about 40 or 50 kilometres. I am quite high up here at over 200 metres, so got a good takeoff in that direction, but nonetheless it's reasonable for a VHF signal. And S-meter hovering somewhere in the middle. The S-meter came in for quite a lot of criticism in the reviews for being so small. It was exactly the same meter on the Mark 1 as it is on the Mark 2, and it is quite small. It's never concern me too much. These days it'd be an LED bar graph, and I think they were a bit baffled. Certainly Chris Lorick was a bit baffled as to why they hadn't put an LCD bar graph onto this display. I suppose the other thing that's interesting is that in the days of minimalist LCDs, of course, you have to put 1.4 in front of that 5. That's just the last megahertz symbol, so that's 145, 475. Completely shuts down 12.5 kcs away. Okay, these guys are a distance away, but I think the rig probably is alright on 12.5 kc spacing. So I'm just wandering up through the repeater to see if there's anything there. I have got a repeater quite close to me, but on 7625, but it's not currently open. So, and I'm certainly not going to be able to open it on this radio because it doesn't have CTCSS. So that's one thing you'll not be doing with this radio, is going on to repeaters. Not much of a repeater user, so I'm not too upset about that. But yeah, that was at the time this radio was produced. There was what was called the tone burst function, which is that call button that sends a 1750 hertz tone, and that was what used to fire up the repeater. If you hadn't got a tone burst, you used to whistle. I've heard a few people do that. So there we go. That's the mobile station now, and you can see there's some flutter on the decimeter as he moves along, fluttering away.
Was to rebuild it as a comms receiver by putting proper filters in and that.
So as you can see, it's working perfectly well from a receive point of view. If I drop onto the other VFO, I've got the other VFO on 144-300, which is the SSB centre of activity, but I haven't got a horizontally polarised beam, so the chances of hearing anything there are pretty thin. Can't hear anything around about there, but there you go. So that's the SSB. So I'm guessing if FM works, SSB will be fine too. Just see if there's anything else down the lower end of the simplex. Nope. 2 meters is very quiet these days. This isn't how it was 34 years ago. Okay, so that's working on receive. Next thing we'll do is we'll get it hooked up to some of the instruments and see what she's like on transmit. Okay, so we'll just start by having a look at the FM transmit. So I've got the rig hooked up to my oscilloscope, and I've also got it on a current limited power supply that gives me a reasonably accurate reading of the current draw. So we'll just switch on. I've picked a frequency that's pretty much right in the middle of the band, in the middle of the 2 megahertz span that the rig actually does. We're running into a dummy load, and I'm just sampling the RF voltage that's going into that dummy load. So we're drawing about 100 milliamps on receive, and that seems to be pretty constant. If I open the squelch, I'm just going to get noise. If I turn that up, it goes up by about 10 milliamps or so, as you might expect as the audio stages drive a bit harder. So just over 100 milliamps on receive for FM. So I'm currently set on low power, so I'm going to key the transmitter on low power, and about 460, 470 milliamps current draw, and we're getting a peak to peak measured voltage on the scope there of about 7.3 volts, something like that. So I'll just do the math there and work out what that is as a power level. You can see the result there. However, I'd take that with a pinch of salt, because the bandwidth of my scope is 100 megahertz, and we're obviously, as you can see there, at 145 megahertz. So I suspect the scope's voltage measurement is somewhat underestimated. Okay, that's low power. I'll just release the transmit. We'll go on to high power. So that's on high power. Just managed to change the frequency, but okay, there we go. So we're on high power now, so I'll key up again, and now we're getting just over 13 volts, about 13.2 volts, something like that, and current drawn is about 878 milliamps. So that's the that's FM. Again, I'd take the measured voltage with a pinch of salt. That would work out, if that voltage reading were correct, as about this many watts. But I suspect, because I'm beyond the bandwidth of my scope, that that's probably not an accurate measurement. However, it is working, and it's only drawing slightly less current than the current drawn on Chris Lorrick's review back in 1987's magazine. Okay, just before we do move on to SSB, just one more quick look at FM, just so we can look at the channel spacing from a modern day 12.5 kilohertz point of view. So I've got the rig on 145 megahertz exactly. So if we key up on full power, we can see the carrier frequency ever so slightly off, not too bad really, just a few hundred hertz. Now I'm going to modulate that with 1900 hertz, so we can see how wide it is, and effectively the either end of the band here, either end of the span, would be the next 12.5 kc spaced channel. So as you can see, it's managing to keep its transmissions well within the 12.5 kilohertz spacing, so that seems quite good. Right, now we'll move on to SSB. Okay, so let's have a look at SSB now. I've not bothered showing you the current draw, because it's it'll just jump about so much, and the digital display won't keep up. FM's a better indicator of that. So I've now got the input of the radio here attached to my function generator, and I've got two frequencies being generated, 700 Hz and 1900 Hz on either channel, and I'm using the Siglent 1032X's built-in wave combine function to give me a combined two-tone wave out of one of the outputs, which is a very handy little function of this machine. And to key the transmitter, I just need to connect that blue wire to the negative lead, and that'll key the transmitter. It's very high tech, but for the purposes of this little test, it works just fine. So we're on low power, so I'm going to key the transmitter, hopefully. There we go, and I'm just going to freeze the display for you, so you can see there we've got reasonably good looking envelope. I've already set the cursors up. I'll just drop them on for you. It's saying the delta there's about just over 7 volts. Again, we're beyond, actually, I think, to be fair, it's probably slightly more. That's probably more like it there, isn't it? So about 7.25 volts. Okay, go on then. Maybe I need to be a bit more generous with it. Yeah, about 7.5 volts, something like that. I do honestly think that that's not an accurate measurement, because I am 50% beyond the maximum bandwidth of the scope. So I was more interested in the shape of the output from the two-tone. So that's low power. We'll now go on to high power and start the scope running again. We'll lose the cursors. We'll key the transmitter. I'm going to just reduce the just tat around with that for a moment or two, just to get it looking a bit more like. There we go. Right, let's now get some cursors back on, and let's see what we're going to get. Obviously we've got a different volts per division there for high power, so that's saying about 18 volts the delta. Let's just move that along, so whoops, so you can actually read it. Yeah, about 18 volts is the delta between those two. And again, Slight change in the top of the outputs of the tones, but nothing I'd be too concerned about. That's pretty clean. We'll have a look in a moment on the spectrum analyzer how that actually looks from a spurious point of view. I picked 500 millivolts as the input amplitude from the signal generator because I actually got the microphone and measured the output on the scope from the dynamic cartridge in there, and it came out between 500 and 600 millivolts when you were talking at a normal volume into it. So I'm trying to be sort of fair to the radio there. So that's the SSB output. Okay, we'll just have a look at performance on SSB. Just got the rig nominally set on 145 megahertz. I've got it on full power. I'm going to apply the two tones from the signal generator again, 700 hertz and 1.9 kilohertz. So we'll just do that now, and I'm just going to capture that wave so we can look at it without having to transmit at the same time. And what you've got here is 2 kilohertz per division. So a lot of the energy is dissipated by 2 kilohertz either side of the center line, and certainly by 4 kilohertz either side it's dropped down quite considerably. So that's probably quite reasonable for a 34-year-old SSB transmitter that probably needs a little bit of alignment now. Okay, that's the SSB performance. Okay, well, hopefully that's given you some idea what this old radio's like. Like I said, my first contact, I think it was the 17th of August 1987 with this very radio, so I think I'll hang on to it now. It's served me well, although it probably needs a bit of alignment. If I'm feeling brave, I might even have a go at that. What I didn't show you was a wider span on the spectrum analyzer for the actual spurious and the harmonics, and actually even on high power it's very difficult to detect anything on the third harmonic, which would fall slap bang in the middle of the 70 centimeter band, but you can barely see anything. So it was clearly well thought out, and is certainly still doing rather well on that front. Okay, I've gone on a bit too much about this radio. This video has already been quite long. Thanks very much for hanging on in there. If you've liked it, please click the thumbs up. If not, you can click the thumbs down. Either way, thanks for watching, and we'll see you on the next one.